Okay, now we shall study few more concepts which are related to spherical mirrors. In that first one, uses of concave mirrors. Coming to uses of concave mirrors are used in torch lights, in searchlights and in headlights of the vehicles to get a powerful parallel beam of light. Next, the concave mirrors, they are used as shaving mirrors to see the larger image of the face. Next, concave mirrors, they are also used by dentists to see the larger image of the teeth just by placing behind it. Concave mirrors, they are used, if it is large in size, large concave mirrors, they are used to concentrate sunlight to produce the heat in solar furnaces in industries. Okay, this is what uses of what concave mirrors. Now let us move on. How are images formed by convex mirrors? Image formation by concave mirrors we already studied at different positions of the object. Now we shall move on to study how are images formed by convex mirrors. Now coming to convex mirror, we consider only two cases. One case is when the object is at infinite distance, that is at infinity, and the second case is when the object is at finite distance. Finite distance means between infinity and pole, anywhere it may be. So two cases we are considering. Let us take first one, when the object is at infinity. How are images formed by that convex mirror? Coming to this, let us draw a convex mirror first. Here, this is convex mirror. Principal axis we have to show first here. Now, this is pole of the mirror. When the object is at infinity, the rays of light coming from that object, they will be parallel to the principal axis. After they are incident on that mirror, they get diverged, as we already studied this. When they get diverged, you can see here direction, they get diverged. Here, after reflection, they are getting diverged. These appear to be emerging from a point on the principal axis, that is called focus. Okay, this is focus. Now, another way we can line we can show here, which is passing through center of curvature, means this is normal to the point of incidence here. So angle of incidence is equal to angle of reflection, that we are showing. Now here, when the object is at infinity, the rays which are parallel to the principal axis, after what reflection, they appear to be diverging from a point on the principal focus. Means what? The object, when it is at infinity, the image is formed at principal focus. The nature of that image is, it is virtual and direct. If it is behind the mirror, it is always virtual and direct, and it is highly diminished or point sized, we say for this. Point sized or highly diminished. And size over location is what? Behind the mirror. Behind the mirror we find this one, position, nature and size. Both, all the three we could understand here. So this is what image formation when the object is at infinity. So the rays of light which are coming through this principal axis, they return in the same path because this is normal to that reflecting surface. Next, let us see when the object is at a finite distance, how are images formed. Means what will be the nature, position and size of the image when the object is at finite distance. Let us take a convex mirror here. Now this is principal axis. When the object is at a finite distance means we are not showing anywhere at a particular point. It is between infinity and pole. Anywhere we can show this. This is pole. We are considering two rays. One ray which is parallel to the principal axis. This, after reflection, it gets diverged. When it is diverged, it appears to be diverging from a point on the principal axis, that is called principal focus. And one more ray we are considering, which is passing through or appearing to be passing through a point on the principal axis, that is called center of curvature. We have to show here this distance of this focal length, it should be half of this radius of curvature, so we need to show it here. Okay, Now you see, the image is formed, where it is formed between P and F. When the object is at a finite distance, the image is formed. This you see, after reflection it follows the same path because it is passing through center of curvature. When the object is at finite distance, the image is formed between P and F. And what is the nature of the image? Image is virtual and direct, and it is formed between P and F behind the mirror. It is behind the mirror between P and F. Next, what is the size? Size is just diminished. We can say it is just diminished size. So these are what? Image formation by what? Convex mirrors. Next, coming to uses of convex mirrors. Where do we use these convex mirrors? Convex mirrors are used as rear view mirrors on automobiles. So that they enable the drivers for safe driving there. When they are fitted on the sides of the vehicles, they show the behind vehicles and objects can be seen through that mirror. It helps in safe driving for those drivers of automobiles. So they are fitted on the sides of the vehicles as rear view mirrors. And these mirrors, as they are having curved outward surface or reflecting surface is curved outwards, they cover a larger area so that we can have a wider field of view through those mirrors. So that is why the convex mirrors, they are always used to see the objects behind the vehicles or traffic of the vehicles. It can be seen through those mirrors. These are just uses of convex mirrors. Now let us come to know few more points, that is sign convention for reflection by spherical mirrors. We are following a set of sign convention that is called a new Cartesian sign convention that we need to follow when we consider the mirrors. While solving some problems, it helps us. Now, let us see what are those sign conventions then. Coming to here, a mirror when you take, here pole of the mirror will be there. If this is a concave mirror, let us take for example, this is a concave mirror. The pole of the concave mirror means center of this concave mirror, it is considered as origin. It is considered as origin according to that coordinate system. It is origin, considered as origin. Now, the principal axis, it is considered as x axis. The principal axis, it is considered as x axis of that coordinate system. And pole of the mirror is considered as origin. Okay, pole is origin here. Coming to the rules, always, here let us take, this is a concave mirror. If I place it here, reflecting surfaces like this, when I place it, the center is considered as origin and the principal axis passing through the pole, it is considered as x axis. Okay. Now, here, coming to the rules, always the objects, they are placed on the left of the mirror. Object will always be on the left of the mirror. This is object. Means what? Light always falls from left hand side to right hand side on the mirror. This we need to consider. The objects are always placed on the left of the mirror. Next, coming to second point, all the distances parallel to the principal axis, they are measured from the pole of the mirror. Okay, they are always measured from the pole of the mirror, to the left or to the right. From the pole only we consider the distances parallel to the principal axis, they are measured from the pole of the mirror. Third point is, now the distances measured to the left of the mirror, they are considered to be negative. They are negative values. The distances measured to the left, because as you already studied in the graph, if this is the graph, let us make this as y-axis and this will be x-axis. Okay. Now, what happens if this is the origin? To the left always there are negative values, right? As you already studied. And if you go to the right, there will be positive values. Means what? the distances measured to the right of the pole of the mirror, they are always considered to be positive values. They are taken to be positive. Next, the distances measured perpendicular and above the principal axis, they are taken as positive values, because if this is y axis, it will be having positive values upwards, right? So they are always considered as positive values if it is perpendicular and above that principal axis. If the distances are measured perpendicular and below the principal axis, perpendicular and below, if it is measured, it will be taken as negative values. These are few set of rules that we need to remember. Okay, once if you remember, we can go for two more concepts, which are there. One is mirror formula, another one is magnification, that we need to learn. These are called new Cartesian sign convention. Now coming to here, if this is the mirror, in front of the mirror, if the object is kept, this distance from the pole of the mirror, distance of the object from the pole of the mirror, it is called object distance, and image will be formed. Okay, when image is formed, let us take this one as convex. In terms of convex, we will take now. So what happens? The image will be formed either behind the mirror or in front of the mirror, right? It will be formed behind or in front of the mirror. This is called, from the pole only it is measured again. Now, distance of the image from the pole of the mirror, it may be behind or in front of it. This is called what? Image distance. This is called image distance. And this is, image distance is denoted as phi, and object distance, it is denoted as u. Okay. Now, this will be having a principal focus. Okay, principal focus. Now, distance between this pole of the mirror and the principal focus, that is called what? The focal length of the mirror, as we already studied. All these three quantities, they are related with one formula, that is called what? Mirror formula. They can be related. These physical quantities, we will show it here in this form. 1 by u plus 1 by phi is equal to 1 by f. Means what? Reciprocal of, the sum of reciprocal of object distance and image distance is equal to the reciprocal of focal length of that mirror. This is called what? Mirror formula. We call this as mirror formula. Okay. Next, coming to here, magnification. What is magnification? Magnification produced by a spherical mirror is nothing but, it is the ratio of the height of the image to the ratio of height of the object. Means what? It is the relative extent to which image is magnified with respect to size of the object. So this is what? Just magnification. It is called magnification. Magnification, it is denoted by the letter m, and this is the ratio of height of the image to the height of the object. This is object height, this is image height, and this is also related with the distance of the image and distance of the object, that is minus phi by u. Minus phi by u, it is equal to this, because this height of the image, height of the object means magnification, it varies depending on the object distance and image distance. Because of that, they are related with object and image distance in this way. So this is magnification formula. This is what? Mirror formula. It is just mirror formula. Now let us take few two examples based on this to apply these mirror formula and magnification, so that we can understand in depth. Now let us take an example first. Say for example, two problems, they are already given in the textbook. Same example I am going to take.